Let's imagine you're walking through a forest 300 million years ago and you make the mistake of observing your surroundings. You might think all you'd see is some dragonflies buzzing around or millipedes crawling on the forest floor, and you'd actually be right. Except now they're 75 times bigger than they're supposed to be and are now able to kill you. You're cooked. And so only logically, if there are giant bugs, there must be giant bug eaters too, right? Well, if you know anything about the Carboniferous period, you'd know this wasn't what happened. The Carboniferous didn't just have big tasty bugs floating around waiting to be eaten. These things were the apex predators. They ate animals, they hunted animals, they ripped apart frogs with giant legs because now they were simply big enough to do whatever they wanted. The earth was ruled by giant insects. So what happened? Why did insects go from being the size of birds, reptiles, and bears to accidentally getting squished by a human toddler? Why would evolution make these creatures weaker over time instead of stronger? And what actually wiped out the age of the giant insects? To understand why giant insects vanished, let's take a look at the most famous massive insect of the Carboniferous, Meganeura. This was a dragonfly, but calling it a dragonfly feels like calling a great white shark a goldfish. Meganeura had a wingspan of over 28 inches, that's over 2 feet across. For reference, the largest possible dragonflies alive today max out at around 7 inches, and most are about 3 inches. And if you saw our first video on this channel about dragonflies, you'd know that modern day dragonflies have the highest hunt success rate out of anything in the animal kingdom. Fortunately, dragonflies today only hunt mosquitoes. So if you put that hunt rate on a creature the size of a hawk, well, you can see why these insects dominated their time period. We often see that with creatures that grow larger, they start to become sluggish and rely more on sheer size as defense and end up eating lots of small things in mass, like plankton. Compare dolphins to blue whales. Both are technically whales, but you don't see blue whales doing sick agility flips. But Meganeura was fast, agile, and built to hunt, just like any normal dragonfly today. Except it was, well, mega. But Meganeura wasn't some rare anomaly. There were giant millipedes, giant mayflies, giant scorpions found all over the world. Here's what makes this era even stranger. These giant insects weren't struggling. They weren't a short-lived species destined towards eventual extinction. They were actually winning quite well. When a species is this successful for this long, it usually means the system is stable. Dominant life forms don't just collapse randomly. So what kind of environment allows the insects to even reach these sizes in the first place? Well, the answer is actually super simple. Nothing was stopping them. Early vertebrates existed during this time. Sure, amphibians were crawling out of the water and primitive reptiles were starting to appear, but they weren't actually threats, or at least not yet. Most were small, slow, and spent their time near water. They weren't built to hunt fast-moving, armoured insects across dry land. In fact, early frogs did exist, but instead of helping control the massive dragonfly population by eating them, the dragonflies were so massive they just ate them instead. Other insects, like Arthropleura, were able to take this to an even bigger extreme than the dragonflies. This was a millipede that could grow up to 8 feet long and weigh over 100 pounds. To put that in perspective, modern millipedes are usually a few inches at most and weigh less than a paperclip. This is a lot different than sized up. It's effectively an entirely new animal that we're talking about. It had thick, segmented armor plating across its entire body, layered like medieval chainmail. When it moved through the Carboniferous forests, it moved like a living tank, shoving aside obstacles and crushing anything underneath its weight. Some paleontologists think it might have been capable of rearing up on its hind segments when threatened, which would have made it taller than a grown human. And here's the strangest part. We're not even entirely sure what it ate. Most modern millipedes are detrivores. They eat decaying plant matter like rotting wood and fungi. Arthropleura probably did the same, just at an absolutely massive scale. It would have ploughed through the forest floor, consuming everything organic in its path. But some scientists have suggested it might have been omnivorous or even partially carnivorous, simply because of how big it was. It could have supplemented its diet by scavenging or eating smaller animals when the opportunity arose. When you're that big and that armoured, you can pretty much eat whatever you want. And nothing could stop it. No predator in the Carboniferous was large enough or strong enough to crack through that armour. Arthropleura had no natural enemies. It just existed, crawling through ancient swamps, eating constantly, growing larger with each molt. So giant insects had ran the planet. No big birds, let alone any birds, diving from above. No mammals chasing them through the undergrowth. No lizards quick enough to catch them. So what was the real reason they died off then? The only thing that could have taken down a giant millipede would be something like a gigantic bird, but those didn't really exist. At least giant flying dinosaurs like pterodactyls didn't yet. Well, being gigantic sounds like a massive advantage, since now instead of frogs eating you, you eat the frogs. But gigantism always comes with hidden costs. Larger bodies take longer to develop. A giant dragonfly nymph had to survive in the water for years before it could even fly, and during that time, it was vulnerable. Larger insects also needed more food, more space, and more energy just to exist. But interestingly, there never was a new predator that killed them off. And the problem also wasn't a crazy shortage of food either. It was just the air. Over millions of years, oxygen levels began to drop. Not quickly, this wasn't a sudden collapse. But slowly, steadily, the atmosphere that once supported massive insect bodies started thinning out. And insects, unlike almost any other animal on Earth, are uniquely vulnerable to changes in the air. But why would something you can't even see be so dangerous? Here's the problem. Insects don't breathe like we do. We have lungs that actively pump air in and out. Our circulatory system carries oxygen directly to every cell in our body. It's an active, efficient system that scales pretty well as body size increases. Insects have nothing like that. Instead, they breathe through tiny holes called spiracles that open along their body. Air diffuses passively through a network of tubes called tracheae, which branch out like microscopic tunnels throughout their entire body. This system works perfectly when you're small, but the bigger you get, the harder it becomes for oxygen to reach your innermost tissues. There's no pump or circulation, just passive diffusion trying to supply a body that's getting exponentially larger. And when the air itself starts losing oxygen, that balance breaks. The biggest insects suffocated first. This is why extinction hit selectively. Small insects could still get enough oxygen even as atmospheric levels dropped. Their bodies were compact, the tracheae was short, and diffusion still worked. But the giants, they were pushing the absolute limit of what insect anatomy could support. As oxygen levels fell, the largest individuals started dying off first, then the next size down, then the next. Over thousands of generations, giant insects didn't go extinct. They shrank to normal insect sizes. The species that survived weren't the strongest, they were the smallest. But insects weren't the only ones adapting to this new world. While insects were shrinking, something else was growing. Reptiles were evolving fast, and they had something insects didn't: lungs. Real active lungs that could pull oxygen out of even thin air. They also had exoskeletons, which meant their bodies could support more weight without collapsing, and they had muscles that could sustain activity for hours, not just quick bursts. Insects were losing the size advantage, and these newcomers were not going to let the history of being bullied slide. So they started hunting back. Being giant can make you a giant deadly predator, but also a giant delicious meal. If there were any giant insects left after the drop in oxygen, the last of them were driven out by actual predators this time. Early reptiles could spot these big bugs from a distance, chase them down, and tear them apart. It took like 300 million years, but yes, the frogs finally got their payback. Smaller insects though can hide in cracks, burrow underground, and reproduce faster than predators could eat them. Gigantism meant you'd die. But even so, why didn't giant insects ever return? You'd think insects could have just evolved better respiratory systems, developed lungs, found some way around the limitation, but they can't. Insect anatomy is built around an exoskeleton, and exoskeletons don't scale the way internal bones do. The larger you get, the thicker your exoskeleton needs to be just to support your own weight. Eventually, you hit a point where the exoskeleton is so heavy that the insect can't even move. Their respiratory system is also hard-coded into their body plan. You can't just add lungs to an insect. The entire structure would need to be rebuilt from the ground up, and evolution doesn't work that way. It modifies what already exists. It doesn't start over. So insects were stuck. Their maximum size was capped, and that ceiling wasn't going anywhere. So what locked it in place permanently? After the Carboniferous period ended, the world stabilized into something that looks much closer to today. Oxygen levels dropped and then leveled out at around 21%, where they've stayed for the past 200 million years. Forests became less dense, predators became more efficient, and insects adapted by staying small. But small doesn't mean weak. Modern insects are faster, more diverse, and more successful than their giant ancestors ever were. Ants can lift 50 times their body weight. Beetles can survive in nearly every environment on Earth. Dragonflies are still some of the most efficient hunters in the animal kingdom, which you'd know if you watched my awesome first video on this channel. There's my shameless plug to get you to go watch it. But there are actually some modern insects today that can kind of reach the old limit of insect size. The heaviest insect in the world is the giant weta from New Zealand, which can weigh over 2.5 ounces, about as heavy as a sparrow. The longest is a stick insect that stretches over 2 feet, but it's incredibly thin and light. And the largest flying insect, that title goes to a species of moth with a wingspan just under 12 inches. Still impressive, but nowhere near Meganeura's 28-inch span. These insects are right up against the ceiling. Their respiratory systems are maxed out for the oxygen today. But could the giants ever return? Hypothetically, it's possible, but it would require a perfect storm of conditions. Oxygen levels would need to spike back up to 30% or higher, and stay there for millions of years, of course. You can't just add some oxygen to an atmosphere and see a giant bumblebee next Tuesday. Predation pressure would need to drop significantly, meaning birds, mammals, and reptiles would all need to decline at the same time. And insect evolution would need to favour size again, which is unlikely as long as being small works so well. Even if all of that happened, insects would still be fighting against their own anatomy. The exoskeleton problem doesn't go away. The respiratory bottleneck doesn't disappear. This pattern repeats constantly in evolution. Dominance doesn't last forever. The moment the environment shifts, the rules change, and what once made you unstoppable becomes the reason you disappear. Giant insects weren't really mistakes or flukes, they were actually perfectly timed. So far, there's only been one good opportunity for bugs to get gigantic, and they took it. All that's left are their fossils, but for those insects, it's one really cool story to be told millions of years later. Unfortunately, insects didn't really evolve smart enough to understand fossils of their mega ancestors even 400 million years later. At least we humans can appreciate it. Thanks for watching, and if you want to finally see that video on how cool modern dragonflies still are, which you totally should, check it out here.